A firm wishes to assess whether there's a linear relationship between the annual amount spent on advertising and the annual profit. Notice that with both of these figures here, because we may need to refer to these later, are in thousands of pounds. And that might be quite important as we talk about our answers later on. A summary of the figures for 12 years is as follows. Calculate the product moment correlation coefficient showing that it is greater than 0.9. That's just kind of giving you a little clue to help you make sure you've got a reasonable answer out of it. Right, so we're going to have to calculate all of our individual things that we need. SXY, which remember was sigma xy minus sigma x sigma y over n. In this case that is, nice of them to give us the key bits of data, 7351.12 minus 86.6 times 943.8, running out of space, over 12, gives us, I use this calculator, while I'm using it. I've got an FX 9680 G2 next door that I could be using. I'm using this. Right, I get 540.03. And if we get a nasty decimal on this, you know what we're going to do? We're going to save it in the memory of our calculator, because we've all got lots of memories in here that we can save it. In fact, I might save this anyway. So I'm going to do Shift and Store and save it in memory A. Right. SX x sigma x squared minus sigma x all squared over n gives us, where is it, 658.76 minus 86.6 squared over 12 gives me that's not very nice, 33.80, but that wasn't exact, so I am definitely going to store that in memory B. There it is stored, brilliant. SYY, so hang on, what have I done? That went in memory A, that went in B, that one's going to go in C, just so I remember for later. Sigma y squared minus sigma y all squared over n is 83,006. We didn't need to write from 0, 0. Minus 943.8 squared over 12. Right. 9433.13. I am, the computer's going to store that in memory C. There it is. Here we go then. R is SXY over the square root of SXX times SYY. I'm sorry, the board is doing a little bit of rotation. But here we go. And now, on my calculator, because I saved all of these, because I was clever with that, I've got alpha A over the square root of BC. And I get 0.956 to 3 significant figures, which is more than the 0.9 that they said it was going to be. And so we can feel happy about that. Great news. Right. Part 2. And we've got them stored, just in case we need them later on. Oh, wow. Comment briefly on this value in this context. Well, what we've just compared is the relationship between advertising and annual profit. We've shown a strong positive correlation. So part 2, we're going to say that there is a strong relationship between advertising spend and profit. There we go. It had to be in context, didn't it? So it's not enough to say a strong positive correlation. That wouldn't get us the mark at all. Part 3. A manager claims that this result shows that spending more money on advertising in the future will result in greater profits. Make 2 criticisms of this claim. Okay?
The opposite can be true. Spending more money, getting more profit can mean greater spending on advertising.
It could just mean that they got more profit. Yeah. Would that? I'm not sure if that's. I think, yeah. I mean, basically, what we're saying. I think the best way of describing that is that correlation doesn't imply causation kind of aspect, because that's the same kind of idea. You're right. It could be one causes the other, or the other causes that one, but there's no implication from that. So the first thing that we can say is that correlation doesn't imply causation, and that's or some way of describing that. And I think what you just said would get a mark for that.
It's like outside of the values of that, or is that like extrapolation?
Well, that's it as well. There's nothing. What we've found here is that over the past 12 years there's been a relationship, but that doesn't suggest that the relationship will continue. So that's exactly the right point. The relationship may not continue. We may have found there to be a relationship in the past, but that doesn't imply it will continue in the future. Which, in a sense, is we're talking about extrapolation, aren't we? And I think, yeah, according to the marks, you get the mark for saying we can't extrapolate. No, it's a good answer. Right, part 4. Calculate the equation of the regression line of y on x. Well, that's the right regression line, that's the one that we're used to calculating. So that's the line that from the formula booklet is the line y equals a plus bx, where b is sxy over sxx. And the great thing is we have those stored on our calculator because we were smart about how we did part 1. So according to what I've got here, that is what I called A, and SXX I called B, didn't I? Yep. So from my stored value, I get 15.979. That's my value. Did it tell us how many decimal places to do with that? It didn't say anything, did it? Okay. To get the value of A is y bar minus b times x bar. So actually I'm going to store that value as well because I'm going storing crazy on my calculator. Stored it as D, even though it's B. So A is y bar, that's the mean of y, so that is sigma y, 943.8 over 12. Minus 15.979 times x bar, which is 86.6 over 12. Oh dear, I can't use this calculator properly. Minus 2 times. And I am getting minus 36.66 7.4 as an answer to that. So it'd be alright to give it to three significant figures here, but I've got minus 36.661, I'm giving it to three decimal places it seems, plus 15.979 times x as my equation of my line. And finally, estimate the annual profit during a year when £7,400 was spent on advertising. Now this is that bit, it almost slipped through without us having to do anything with it. But remember, X in thousands, Y in thousands. So this is X, the advertising is £7.4 thousand. So for part 5, X is 7.4, so Y would be minus 36.664 plus 15.979 times 7.4, which gives a Y value of 81.58. And that wouldn't be enough for the right answer either, would it? Because the right answer is, that's different to what it says in there. Oh, the right answer is 81,600 if we do it to three significant figures. They accepted any answer from 81,400 to 81,750. I've just happened to be using really exact values because I've got them all saved, because I'm very skilled with the calculator. Right, and that's maths.